Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. Okay, my dear children. In this chapter, we are going to discuss the problems in the exercise 7.5. In the previous class, we have discussed 5 questions so far in this exercise. Okay, my dear children. See page number 322 in the textbook. Okay, my children. In this exercise, we are integrating the rational functions of different types. This is type 1. First, question number 1 to question number 6. These are all comes under type 1. What is the type 1? When the denominator is expressible as a product of distinct linear factors. If you observe the rational function the denominator can be written as a product of two linear factor. Observe here, this is a linear factor. X is one linear factor, 1 minus 2x is another linear factor. Both are distinct linear factors. Okay, my children, understood this one? Right. Come to the question number 6. Integrate 1 minus x square by x into 1 minus 2x. Okay, my children. Understood this question? We have to find the integral of this function. Okay, my children. Now come to the solution part. Let capital letter I is equal to integral 1 minus x square by x into 1 minus 2x dx. Understood this first step, my children? Right. First of all, what I said, we have to verify whether the given function is a proper rational function or not. First, we have to check that part. Otherwise, the integration of rational functions by using partial fractions cannot be used for improper rational functions. That method is used only for proper rational functions. Okay, my children. Right. Now let us write the integrand. What is the integrand here? Integrand p of x by q of x, where p of x is equal to 1 minus x square and q of x is equal to x into 1 minus 2x. Okay, my children, this is the integrand. We wrote p of x by q of x. Numerator is a polynomial in x, and as well as in the denominator, it is also a polynomial in x, product of two linear factors. Now let us write the degrees of p of x. Degree of What is the degree of this numerator polynomial? Yes, 2. Highest power of x, exponent, highest exponent of x, that is 2. So degree of this polynomial is 2. Understood this step, my children? Right. Come to the denominator. Let us write the degree of q of x. How can you find degree of this q of x denominator? Previously I told you, here exponent of x is 1, here also exponent of x is 1. So we are multiplying, means we have to use a power m into a power n. Then what do you get? A power m plus n. So 1 plus 1. So here the degree of denominator is 2. Understood this step, my children? Right. Now if you observe here, degree of p of x is equal to 2 and the degree of q of x is also 2. Then what can you say about this rational function? It is a improper rational function. Here degree of degree of p of x is equal to degree of q of x. Then we say that therefore p of x by it is a improper rational function. So we can't use integration of improper integration of rational functions by using partial fractions method. So before to use that method, we have to convert we have to transform this improper rational function into a proper rational function by using long division. Okay, my children, right? This can be taken as 1 minus x square by x into 1 minus 2x. Again, I am taking this rational function. Okay, my children, here we are converting this improper rational function into a proper rational function. So 1 minus x square. Here what will get? Use the distributive property, x into 1. What will get? X minus 2x square. Minus 2x into x. What will you get? Minus 2x square. Understood this denominator, my children? Right. Now let us take minus common in the numerator. So minus of x square minus 1. In the denominator also take minus 1. So 2x square minus x. Understood this step, my children? Right. Then strike out minus minus. What will you get? X square minus 1 by 2x square minus x. Okay, my children, we converted this rational function into our convenient form. Okay, my children, understood. Now we have to divide this numerator by this denominator. Here we use long division. Okay, my children, understood? Right. Now come to this part, my children. Long division. We are converting this improper rational function into a proper rational function with the help of long division. So here we have to divide this polynomial by this polynomial. So I wrote here this one, x square minus 1. We are dividing this polynomial by this polynomial. Then how do you divide? We take here first term. What is the first term here? X square. X square by, what is the first term here? 2x square. Do you remember these steps, my dear children? Long division. Dividing a polynomial by another polynomial using long division. What do you get here? 1 by 2. We write the 1 by 2 as a first term of this quotient. Okay, my children, 1 by 2. So we multiply 1 by 2 into 2x square minus x. Okay, my children, right. Now let us multiply. Distributive property. What will you get? 1 by 2 into 2x square minus x by 2. I wrote these two terms directly by multiplying these two terms by 1 by 2. Understood this step, my children? Right. We write this product under this one. Okay, my children. So here x square minus x by 2. Okay, my children. Here x term is not given. For our convenience, we can write 0 into x minus 1. Do you remember this point also, my children? X square term. In general, we have to write the polynomial in the standard form. Means in the descending powers of x. So x square term. Next we have to write x term. But actually x term is not there. So for our convenience, we can write like this. Minus 0 into x or plus 0 into x. You can write as your wish. Next constant term. That is why we wrote this polynomial like this. Okay, my children. Now we are multiplying this one and we got this polynomial. Now simplify here. X square gets cancelled. What we get? X by 2. X by 2. We carry down minus 1. If you observe this polynomial in this stage, if you observe this polynomial, degree of this polynomial is 1. Here degree of the polynomial is 2. So we stop this long division. When we get the degree of this polynomial is less than the degree of this polynomial, we stop this division. So this is the remainder. Okay, my children, this is a remainder. Then we write this long division as a mixed fraction. Therefore x square minus 1 by 2x square minus x is equal to, How do you write? Quotient plus remainder x by 2 minus 1 whole divided by 2x square minus x. 2x square minus x. Okay, my children, understood this step. I wrote as a mixed fraction. Quotient plus remainder by this divisor. Okay, my children, understood this one? Right. This is nothing but given integrand, isn't it or not, my children? So this implies, again we write as a given integrand. So 1 minus x square, 1 minus x square by x into 1 minus 2x. This can be written again as a given integrand. The given integrand 1 minus x square by x into 1 minus 2x is equal to, we got a quotient, this one 1 by 2 plus this is a remainder whole divided by divisor. Okay, my children, right. Now let us write this part. This implies 1 minus x square by x into 1 minus 2x is equal to 1 by 2 plus, if you take LCM here, what will you get? X minus 2, x minus 2 by 2 into 2x square minus x. Okay, my children, I have taken LCM here. Then we get x minus 2 in the numerator and bringing this number 2 to denominator. Then 2 into 2x square minus x. Okay, my children, understood this step? Right. This implies 1 minus x square by 1 x into 1 minus 2x is equal to 1 by 2 plus x minus 2 by 2 into, what will you, let us write as a product of two linear factors. Let us take here x common. What will get? 2x minus 1. Okay, my children, understood this part? Right. Now if you observe this part, this is a proper rational function. Then we can write partial fractions for this proper rational function. Here x minus 2 by x into 2x minus 1. I am not taking this numerical coefficient, my children. I am taking it later. I am taking that one later. I am taking only this part. X minus 2 by x into 2x minus 1 is a proper Now for this proper rational function, we can write the partial fractions. Let us write or decompose this proper rational function into partial fractions. As shown below. As shown below. Okay, my children. Let us consider this is equation 1. Let us consider that is equation 1. So we are taking only this part, x minus 2 by x into 2x minus 1. For this proper rational function, this is a proper rational function because the degree of this polynomial is 1. Here the degree of the polynomial is 2. Then it is a proper rational function. Understood this point, my children? Why this rational function is a proper rational function? Right. Now we decompose, we rewrite this proper rational function as partial fractions. So let x minus 2 by x into 2x minus 1 is equal to If you observe here, this is a non-repeated linear factor. This is another non-repeated linear factor. For corresponding to every non-repeated linear factor, we have to write one partial fraction. So, a by x. X is a non-repeated linear factor. So, a by x. Understood this partial fraction, my children? Right. Plus, second non-repeated linear factor is 2x minus 1. For this corresponding to, for this non-repeated linear factor, we write another partial fraction. This is another partial fraction. Understood this point, my children? Right. Let us consider this is equation 2. Let us consider this is equation 2. In this equation, we have to find the values of a and b. Okay, my children? Right. This implies x minus 2 by x into 2x minus 1, x into 2x minus 1 is equal to, let us take here LCM. Here onwards, you follow the steps as we followed for the question number 1 and question number 3 for finding the values of a and b. Okay, my children, we take LCM for the denominators. Then what will you get in the numerator? A into 2x minus 1 plus b into x. Understood this step, my children? Right. Now, let us strike out these denominators. Understood this step, my children? Right. This implies what you will get here? X minus 2 is equal to a into 2x minus 1 plus bx. Let us consider this is equation 3. Let us assume that this is equation 3. Okay, my children, understood this one? Right. Let us find the values of a and b. Okay, my children. Now, what is the first linear factor? X. Isn't it or not, my children? So, put x is equal to 0. This is a rough work. Directly we got the here x value. So, put x is equal to 0 in this equation 3. Put x is equal to 0 in the equation 3. We get, let us substitute x is equal to 0 in this equation 3. Then what will you get? 0 minus 2 is equal to a into 2 minus 0 minus 1 plus b into 0. Understood this step, my children? In this equation 3, I substituted x is equal to 2. Then we get this step. Understood this step, my children? Right. Now let us simplify this step. This implies 0 minus 2. What will you get here? Minus 2. Here a into 2 into 0. What will you get? 0 minus 1. Final what will you get? Minus 1. Plus here second term b into 0. What will you get? Second term is 0. So I am not writing the second term. I wrote only first term. Okay, my children, understood this step? Right. Let us simplify this one. Here minus minus gets cancelled. Therefore, a is equal to 2. So value of a is equal to 2. Understood this step, my children? Right. Now come to the second non-repeated linear factor. What is the non-repeated linear factor? 2x minus 1. 2x minus 1 is equal to 0. This is also should be done in rough work. From this equation, solve x is equal to, we have to find the value of x. What you got here? Value of x 1 by 2. So put x is equal to 1 by 2 in the equation 3. Put x is equal to 1 by 2. By substituting x is equal to 1 by 2 in the equation 3, we get 1 by 2 minus 2 is equal to, okay, my children, 1 by 2 minus 2 is equal to a into 2 into 1 by 2 minus 1 plus b into 1 by 2. Understood this step, my children? By substituting x is equal to 1 by 2 in this equation 3, we get to this step. Understood this step, my children? Right. This implies, let us simplify LHS. 1 by 2 minus 1. 2 2s are 4. 1 minus 4. What will you get? minus 3 by 2. Finally, what we get? Minus 3 by 2 is equal to. Now come to the first term. Let us simplify the first term. Here 2 gets cancelled. What will you get here? 1 minus 1. What is the value of 1 minus 1? 0. So a into 0. So 0 only. So first term is 0. So I am not writing the first term. Now come to the second term. What is the second term? B into 1 by 2. What will you get? To b by 2. Okay, my children. Understood? Right. This implies 2 gets cancelled. What will you get here? B is equal to minus 3. So we got the values of A and B. Now let us substitute these two values in the equation 2. Substitute A is equal to 2 and B is equal to minus 3 in the equation 2. The equation 2 we get, what is the equation 2? X minus 2 by. X minus 2 by. Do you remember that one? X into 2x minus 1 is equal to 2 by x. A value is 2. So 2 by x plus b by means minus 3 by 2x minus 1. We got this one. So we have decomposed this proper rational function into partial fractions. Okay, my dear children, we got these two partial fractions. Now let us take this result. Let us substitute this result in the equation 1. Okay, my dear children, understood? Right. Now we are substituting x minus 2 by x into 2x minus 1 is equal to 2 by x minus 3 by 2x minus 1 in the equation 1. We get 1 minus x square by x minus 2x. Okay, my dear children, in the equation 1, we are substituting this value. So 1 by 2 plus 1 by 2 of 2 minus x minus 3 by 2x minus 1. Okay, my dear children, understood this step? Right. Now integrating on both sides. Integrating. By integrating on both sides, we get integral 1 minus x square by x into 1 minus 2x dx is equal to integral, here two terms are there. So, okay, 1 by 2. Let us simplify these terms also by distributive property. Integral of 1 by 2 plus 1 by x. I am writing directly the second term. 1 by 2. 2 gets cancelled. 1 minus x minus 3 by 2 into 2x minus 1 dx. Understood this step, children? By using the distributive property, I wrote these two terms. I wrote this first term as it is. Okay, my children. Now we find the integral of each and every term separately. Okay, my children. Right. Therefore, I is equal to 1 by 2 integral dx. Here, first term is 1 by 2. It is a numerical coefficient. So, integral 1 by 2 can be written as 1 by 2 into integral dx plus integral 1 by x dx. Second term is 1 by x. So, integral 1 by x dx minus 3 by 2 integral 1 by 2x minus 1 dx. Understood this step, my children? We are finding the integral of each and every term separately. This is equal to 1 by 2 into integral dx. Integral dx means integral 1 dx means x only. Plus integral 1 by x log mod x. Okay, my children, these are all well known integral formulae. Okay, my children, minus 3 by 2 into 1 by 2. It is in the form of integral 1 by ax plus b. What is the formula? 1 by a log mod ax plus b, that is 2x minus 1. Understood this step, my children? Understood this third term? I will write here formula. Integral dx is equal to x. For the first term, we wrote this, we used this formula. For the second term, integral 1 by x dx is equal to log mod x. This formula is used for this second term. And integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b. This third formula is used for this third term. Okay, my children, where a is equal to 2. So 1 by 2 log mod 2x minus 1. Understood this step, my children? By using these three integral formula, we got this step. Okay, my children, right. This implies x by 2. Let us simplify the terms. X by 2 plus log mod x minus 3 ones are 3 by 4 log mod 2x minus 1 plus c. We have simplified the terms also, my children. So this is the last step. At the last step, we have to add the constant of integration. Understood, my children? Right. So from question number 1 to question number 6, these are all comes under the type 1. In this total exercise, there are only 3 types of problems will be given. In this evaluating, integrating into evaluation, the evaluation of integral a rational function. There are only 3 types. Okay, my children, this is the first type. When the denominator has non-repeated linear factors, distinct non-repeated linear factors. Okay, my children, right. Come to the type 2, evaluating integral of rational functions by using partial fractions method. Okay, my children, this is type 2. When denominator contains some repeating linear factors. In the previous type 1, type 1, the denominator contains only non-repeated linear factors. Isn't it or not, my children? If you observe the question number 1 to 6, denominators are non-repeated linear factors. Whereas, come to question number 8. This is type 2. And one more type is there. Only 3 types are there in this exercise. Okay, my children. I will explain third type in the next class. Okay, my children. See, integrate x by x minus 1 whole square into x plus 2. If you observe this rational function, it is a proper rational function. First and foremost thing is the rational function should satisfy that first condition. What is that first condition? That rational function should be proper rational function. Only for proper rational functions we can write partial fractions. Okay, my children, keep this point in your mind. So here it is a proper rational function. So I am not again verifying this rational function is a proper rational function or not. I am not doing that part. Okay, my children, directly I am doing the remaining part. Okay, my children. So this is a proper rational function. Integrand here, integrand is a, directly I am writing here. Here integrand is a proper rational function. Because degree of the numerator is 1 and the degree of the denominator is equal to 3, because here we get x square. Isn't it not, my children? If you expand this expression, what you get? X square into x. What you will get? X cube. So highest power of x in the denominator is 3. Okay, my children, not 2. Don't be confused here, my children. That is why I wrote here clearly. Degree of the numerator is 1. The highest power of x, the highest exponent of x is 1. So degree of the numerator is 1. Degree of the denominator is 3. Don't be confused. Not 2. Not the degree of the denominator 2. 3 only. Okay, my children, understood this point? Right. So it is a proper rational function. So only for proper rational functions we can write partial fractions. So here, if you observe the denominator, so let x by x minus 1 whole square into x plus 2. If you observe the denominator, it is a repeated linear factor. X minus 1 is actually a linear factor, but whole square is there. Whole square, whole cube. Like this it is given that factor is called repeated factor. So x minus 1 is repeated 2 times. How many times this linear factor is repeated? 2 times. So corresponding to this repeated linear factor, we have to write two partial fractions like this. A by x minus 1. First partial fraction is a by x minus 1 plus b by x minus 1 whole square. Okay, my children, because it is repeated 2 times, so we are writing two partial fractions corresponding to this repeated linear factor. Understood these two partial fractions, my children? Right. Plus one more linear factor is there. This is non-repeated. Not whole square is there, not whole cube is there. So this is a non-repeated linear factor. So corresponding to this non-repeated linear factor, we write a partial fraction like this. C by x plus 2. Understood this three terms? Understood these three partial fractions, my children? Right. Let us assume that this is equation 1. Let us consider this is equation 1. In this equation, we had to find the values of A, B and C. Okay, my children? Right. We follow the same steps as we followed for the previous questions. X by x minus 1 whole square into x plus 2 is equal to, let us take LCM here. What will get? X minus 1 whole square into x plus 2. Don't be confused here, my children. Denominators x minus 1, here x minus 1 whole square into x plus 2. Don't write all these product of these three factors. X minus 1 whole square into x plus 2 only. The LCM of these three denominators. Okay, my children? Right. Then what will you get in the numerator? A into, here x minus 1. X minus 1 gets cancelled. 1 x minus 1 get under x plus 2. Understood this one, my children? This number by this number. Simplify it in the rough work. X minus 1 gets cancelled. Then x minus 1 into x plus 2 will be left. So a into x minus 1 into x plus 2. Okay, my children, this is the first term. Right. Plus again this denominator by this denominator. What will get? Do that part in rough work. These two gets cancelled. X plus 2 will be left. So b into x plus 2. B into x plus 2. Understood this is the second term, my children? Right. Plus, let us take the third fraction. X by 2, x plus 2. These two gets cancelled. X minus 1 whole square get. So, x minus 1 whole square. We get a c into x minus 1 whole square. Understood this is denominator and numerator, my children? Right. Now, let us strike out denominators on both sides. Then what will get? X is equal to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 whole square. Let us consider this is equation 2. So in this equation 2, we have to substitute the values of x. Okay, my children. How to substitute x values? We have to take the linear factors in rough work. We have to take the linear factors and we substitute the x values in this equation 2. Okay, my children? Right. Okay, my children, this is equation 2. In this equation 2, first we have to write the non-repeated linear factor. What is the linear factor here? In the rough work, x minus 1 is repeated linear factor, whatever it is, repeated linear factor or non-repeated linear factor. Let us take that linear factor here and we find x value. So x is equal to 1. We got here x is equal to 1. So put x is equal to 1. Put x is equal to 1 in the equation 2. In the equation 2. In this equation 2, put x is equal to 1. Then what will you get? 1 is equal to a into 1 minus 1 into 1 plus 2 plus b into 1 plus 2 plus c into 1 minus 1 whole square. Understood this step, my children? In this equation 2, by substituting x is equal to 1, we get this step. Now, let us simplify this step. Okay, my children? Right. This implies 1 is equal to, if you observe here, 1 minus 1, what will you get here? 0. 0 into any number, we get 0. So, first term is 0. So, I am not writing the first term. Okay, my children. Now, come to the second term. What will you get here? 1 plus 2, 3. B into 3. What will you get? 3b. I wrote the second term directly. Understood this 3b, my children? Right. Now come to the third term. 1 minus 1. What will you get? 0. 0 whole square. 0. So c into 0. What will you get? 0 only. So third term is also 0. First term is also 0. Third term also 0. So I did not write first and third term. Okay, my children? Wrote only the second term. Understood this step, my children? Right. This implies b is equal to 1 by 3. By solving this equation, we get b is equal to 1 by 3. We got b value. Okay, my children. Now come to the second linear factor. What is the second linear factor? X plus 2 is equal to 0. So, what will you get here? X value? Minus 2. So, substitute x is equal to minus 2. Put x is equal to minus 2 in the equation 2. Let us substitute x is equal to minus 2 in this equation 2. Then what will you get? Minus 2 is equal to a into minus 2 minus 1 into minus 2 plus 2 plus b into minus 2 plus 2 plus c into minus 2 minus 1 whole square. By substituting x is equal to minus 2 in this equation 2, we get to this step. Understood this step, my children? Right. Now let us simplify this step. Okay, my children, this implies minus 2 is equal to, if you observe this first term, in this brackets minus 2 plus 2, what will you get? 0. So 0 into any number, we get 0. So first term value is 0. That is why I am not writing first term here. Okay, my children, understood? Right. Come to the second term. In this brackets, what will you get? Minus 2 plus 2, here also we get 0. So b into 0, we get 0. So I am not writing second term also. Understood this point, my children? Right. Plus c into minus 2 minus 1. What will you get? Minus 3. Minus 3 whole square. What will you get? 9. 9c. I wrote directly that value, third term value. Understood this term, my children? Understood this step? Right. This implies c is equal to minus 2 by 9. We got the value of c also. Understood this step, my children? Right. We got a b value and a c value. We have substituted, we have taken the linear factors and we got x values. Okay, my children? But there are no other linear factors. Then how to find a value? In this case, we have to equate the coefficients of x square on both sides. The highest power of x, what is the highest power of x on LHS or RHS? X square. The highest power of x is x square. So comparing or equating coefficient of by equating the coefficients of x square on both sides, we get In LHS, is there x square term? So its x square term is not there. Its coefficient is 0. Understood this part, my children? 0. Now come to RSS. From this first term, a into x square, x into x, what will you get? X square. So coefficient of x square is a. From the first term, we get x square coefficient is a. From this second term, will you get x square term? We cannot get x square term from this second term. Now come to the third term. In this third term, x square is there. If you expand this expression, what will you get? X square minus 2x plus 1. I am not doing that part. Then what is the coefficient of x square? C only. So plus C. Understood this step, my children? You have to expand this one also. Then you can find the coefficients of x square is a plus c. Okay, my children, understood this step? Right. This implies 0 is equal to a. C value we got already, minus 2 by 9. This implies a is equal to 2 by 9. Understood this step, my children? We got a value is 2 by 9. B value is 1 by 3 and C value is minus 2 by 9. Okay, my children. Now we substitute these three values in the equation 1 and later we integrate. Okay, my children. Understood? Right. Okay, my children. Let us substitute A is equal to 2 by 9, B is equal to 1 by 3 and C is equal to minus 2 by 9. In the equation 1, we get x by x minus 1 whole square into x plus 2 is equal to, we wrote a by x minus 1. So 2 by 9 by x minus 1 plus 1 by 3 by x minus 1 whole square minus 2 by 9 x plus 2. Okay, my children, understood this step. Now let us integrate on both sides. So integrating integral x by x minus 1 whole square into x plus 2 dx is equal to 2 by 9 integral 1 by x minus 1 dx. Here I am writing the directly integrals plus 1 by 3 integral 1 by x minus 1 whole square dx minus 2 by 9 integral 1 by x plus 2 dx. Here I wrote this step directly by taking the integrals of these three terms separately. Okay, my children? Right. This implies I is equal to 2 by 9. It is in the form of integral 1 by ax plus b. That is equal to log mod x minus 1. Okay, my children, understood the integral of this first term? Right. Plus 1 by 3 into, now it is in the form of integral 1 by x minus 1 whole square. This can be written as integral x minus 1 whole square minus 2. We wrote that second term as x minus 1 whole to the power of minus 2. Can we write this term as x minus 1 whole to the power of minus 2 or not, my children? Right. Minus 2 by 9. This also can be written as log mod x plus 2. Integral of this last term also same as the first term, because integral 1 by ax plus b dx is equal to 1 by a log mod log mod ax plus b, and this is written by using this loss of exponents. The second term is written by using this loss of exponents. Okay, my children, understood this one? Right. This implies I is equal to 2 by 9 log mod x minus 1 plus 1 by 3. Now it is in the form of integral ax plus b whole to the power of n dx. What is the formula? 1 by a. So that is 1 by minus 2. Sorry, 1 by a. What is 1 by a? Here 1. A means coefficient of x. 1 by a. X to the ax x minus 1 whole to the power of minus 2 plus 1 by minus 2 plus 1. Okay, my children, integral x to the power of n formula. Minus 2 by 9 log mod x plus 2, because for this middle term we used this formula integral ax plus b whole to the power of n dx. If it is a linear expression in x whole power n, this can be written as 1 by a into ax plus b whole power n plus 1 by n plus 1, where a is equal to 1, b is equal to minus 1 and n is equal to minus 2. Okay, my children. In this formula we substituted a, b and n value. Then we get this step. Okay, my children, understood? Right. This implies I is equal to 2 by 9 log mod x minus 1. What will get? Minus 2 plus 1, minus 1. So minus 1 by 3. Finally we get, by simplifying this term, finally we get to minus 1 by 3. X minus 1 whole power minus 1. How can you write? X minus 1. 1 by x minus 1. Okay, my children, I wrote directly. Minus 2 by 9 log mod x plus 2. This is the last step. So at last step we add constant of integration. Understood, my children? So direct I wrote this is second term. Okay, my children, right. Please do the remaining questions in this exercise which are of type 2 by observing the question in the denominator which are having repeated linear factors. Repeated linear factors. Some factors are non-repeated linear factors and some factors are repeated linear factors. Okay, my children, right. Will you do the remaining sums in this exercise by using this question? Okay, my children, same as this question number 8. Okay, my children, try them. Right.